Good morning, class. This is Mr. Roberts at Shasta High School. Welcome to those of you that are staying home today. Uh, Today we are going to be covering section 1.2.3. Specifically, we'll be talking about the domain and the range of a function. What is a function's domain? What's its range? And more on that in just a moment. But first of all, I want to review just our definition from yesterday. We spoke specifically about what is a function, and we have this definition. A function is a relationship between inputs and outputs. Um, and we like to say that you have a function if it is the case that there is exactly one output for each input. So it's possible that some inputs don't have outputs, and that's okay. We're going to talk about that in terms of the domain today. But if you do have outputs for a specific input value, if you place a value in, it can have no more than one, right? It has to have, if it's going to have one, it has to have exactly one. Um, so I can give you a couple examples of functions. So this is a function. And I probably gave you the more the one that makes you say what first, but that's okay. If you look at this specifically, the value of 3 is only and always going to give me 2, right? 3 gives me 2, 3 gives me 2, 3 gives me 2. You can see there's no other point when I put in 3 that I get something other than the number 2. 5 is giving me 6, 5 only gives me 6, and 4 is giving me 2, and 4 is only giving me 2. And it's perfectly fine that two different values are producing 2, right? I can have 3 can be giving me 2 and 4 can be giving me 2. But if 4 ever said anything in addition to 2, if 4 went to both 2 and 7, it's not a function. Here's another example of a function. This is probably the one I should have started with, right? 1 is only going to 4, 3 is only going to 6, 8 is only going to 7. I say 8, it says 7. I say 8, it says 7. 8, 7, 8, 7. You get the idea. Now down here, this is a non-function. And it is a beautiful relationship, but the reason why we say this is a non-function is because you can see sometimes when I give this function 3, it might produce 2, and sometimes when I give this function 3, it might give me 6. That's non-functional, right? I need functions need to be consistent and predictable. If I give it 3, and I don't care which one it gives me, if it can give me 2 or it can give me 6, but it can't give me both. And this is a non-function because you can see 3 has two potential outputs. At this point, I would like for you to pause the video for just a moment, and there are 5 vocabulary terms I want you to get into your notebooks from section 1.2.3. And the vocabulary terms are function, independent and or dependent and independent variables, and domain and range. And again, if you hover over these and click them in CP/M, it'll give you a nice complete definition there. But I want you to make sure that you understand what those 5 words are and that you have them written down. So please pause the video, get those 5 items into your notes. Okay, so let's get into the heart of this section today. This is section 1.2.3. That's cute. And the title is What Can Go In, What Can Come Out. And it says, and I'll read to you, sorry about that. You have several characteristics that you can use to describe graphs using the questions that you began to develop in 1.1.3. You've also learned how to tell if a graph represents a function. Today, we're going to complete our focus on functions by describing the inputs and outputs of relationships. Okay, so if I move on to this first graphic, and I'm just going to show you this graphic here, the first thing I want us to focus on is a couple quick questions. So if I told you that this was a function and the name of this function was f, I could say it's f of x and it's that graph. I could, for example, ask you, well, if you were to give that function the value -4, if you gave it negative 4, remember these are the inputs, this is what's going into it, and my inputs are along the x-axis. Here's the x-axis. You can see at negative 4, this function is saying, it's saying, you know, somewhere a little bit less than negative 3, like maybe negative 3.6. So we might be able to say like, well, it looks like it's about negative 3.6, right? But you can see that's the value right there that we're talking about when I give it the number negative 4. If I was to give this function, for example, the value 1, here goes 1 into that function. If 1 goes in, again, that's my domain. It's a value from the x-axis. If 1 goes in, it's reporting back, oh, it looks like it's negative 3. So when 1 goes in, it gives me negative 3. One more question I want us to consider. If I place the number 4 into this function, right? If 4 is my input, you can see, oh, wait a minute. Why did you just call that a function? You just said function. And this is not a function, is it, right? I'm using function notation. I'm saying f of x, but it becomes very clear right now this is not a function because you can see I have no less than 1. And actually, it could give me 0 also. So this is also an output. And here's a third output. So you can see that there's 3 outputs there, right? 3 outputs for that 1 input. So this is not a function. So this is it's a nice relationship, but the relationship is not a function. Let's look at a function that's defined like this. Clearly, there's a lot of values we can put into this. If I wanted to, I could look at what happens if I put a 0 in. Let's say I put in 0. I'm going to write it like this. I'll make a little table. So here's my inputs, and here's the value of f of x when I evaluate it. If I place 0 into there, this becomes 0, right? And this simply becomes 6 divided by 0 minus 3, or 6 divided by negative 3, which is going to be negative 2. So 0 produces negative 2. If I was to place negative 3 in it, right? If I was to put a negative 3 into that function, a negative 3 minus negative 3 in my denominator, right? This becomes negative 3 minus 3. That becomes negative 6. Well, 6 divided by negative 6 is negative 1. That's beautiful also. And I could put 2 in there. If I put 2 in, this becomes 6 divided by 2 minus 3. 2 minus 3. 2 minus 3 is negative 1. 2 minus 3 is negative 1. So that becomes 6 divided by negative 1, which is negative 6. Now, I want you to consider this value. If I was to place 3 into this function, right, what becomes my output? And at first glance, you're like, okay, this is going to become 6 divided by 3 minus 3. This is going to become 6 divided by 0, right? A lot of times we're tempted to say different things, like, and we'll just start kind of like taking stabs at guessing it. But if you're not sure what that equals, I encourage you to just take your calculator, any calculator, and go 6 divided by 0. Or ask Siri or ask Google, hey, what's 6 divided by 0? And see what response you get. And I'll tell you what you're going to get. You're going to be told that this is undefined. Right? Division by 0 is undefined. And what that means is that this function has a restriction on its domain. The domain is the collection of the values that I can place into that function. This particular function has a restriction on the domain. I cannot place positive 3 into it, because if I place positive 3 into it, I get this division by 0 phenomena. So that is a domain restriction. Let's take a look at another graph. Here's a beautiful little graph, and I'm calling this function g of x. G of x. Now I want you to note something about this function. Unlike the first one that I showed you, and I can go back to that first graph, right? On this first graph, I want to point out that there are some arrows here and here, indicating that this thing continues to go in both directions infinitely, right? So it continues on in that function, in that fashion, both forward and backwards. For this particular one, right, there's just a solid dot right there, a solid dot, a solid dot, and that implies that this function does not speak to me over its entire domain. The domain are all of those values, right? All of those values along here in which I can place into it. The domain are my input values, they're my x values. And if you look at it, I'm going along here, and for a chunk of the domain, this thing says, I got nothing to say to you, right? And it makes me very sad. I put in -3, I put in -3, and it's like, I don't know. I put in -4, I put in -5, no. Negative, I put in -3.5 right here, this value, right? And I don't know where that goes. It's not showing me on the graph. The g of x is saying, I got nothing to say. And it continues to do that until I get to this value, -2. And as soon as I place -2 into the function, it's like, oh, -2? You're going to ask me about -2? I can tell you about that. When you give me -2, I'm going to tell you +1. So this function starts giving me values, this function g of x starts kicking out outputs at -2. And it will tell me things about -1, 0, 1, 2, 3, 4. This entire block, everything in here, I'm just going to scribble this in, all of these x values, and in fact, including those endpoints, this function g of x says, I got an output for you. When I say 4, it says -1. If I say 2, it looks like it's saying, it might be saying +1, right? If I say 1, I don't know. If I say 1, maybe it's saying 2.5, right? If I say 0, it looks like it's saying 1, 2, I don't know. It could be, I don't know. This is not scaled well. If that's 1, that's 2. It could be 3, right? If I put in 2, it says 3. But the point is that it says something, right? It says something for all of those values. As soon as I go beyond 4, this function stops talking to me, right? If I put in like 4.1, it's like, get out of here, right? I got nothing to say. If I put in 5, nope, nope. The only time that this function's speaking to me is in this very specific chunk of numbers, right? This chunk of numbers that starts at -2 and it continues, including -2, and it continues all the way until the number 4. This is the domain of this function. This function contains all the values from -2 up to and including +4. Now, this function also has something that I call the range. That's the value of the outputs that are possible for it. So I'll switch a color. I'll use green for the range. So it looks like the largest value I'm ever going to get out of this function is, I'm going to say 3, right? This is where g of x gives you 3, and it happens when x is 0, or I can say when y equals 0. Oh no, not when y equals 0. When x equals 0, y is 3. So this looks like its maximum functional value. That's the biggest value I can get out of it. The range are all those values that are possible to receive from a function. So this function can clearly give me 3, and it looks like the smallest value this function can give me is way down here at -1. So everything in this area right here they are within range of this function. I can pick an x value that'll give me one of those numbers. I can pick, if I pick 2, it's going to give me the 1 we said. But I can't get anything larger than 3, and I certainly can't get anything smaller than 1. So this function has a range, and the range of this function I'll write in green. This range starts at -1, right? And it includes it, and it goes up to and includes the number 3. So I'm using the word inclusive here, and the reason why I'm saying it includes those points is because I'm using it has this solid dot, which implies something. It tells me something about whether or not that point is in the function or not. Because it's a filled in dot, it implies that it is in the dot. So that's the range of the function. The range is any number from -1 up to 3. So we've seen how we can look at a function, right? We can look at it and we can determine the range and the domain by looking at a graph of the function. But one of the things that we might have to deal with is sometimes we're just going to have the function rule. And we could certainly graph this, but sometimes it's not going to be really obvious just by looking at the graph what the domain and the range are. So I want to point out two things that I think you should be aware of and think about whenever you're asked to describe domain and range. And one of them is division by 0. And the idea here for division by 0 is, look, if you end up putting a value into a function that causes the function to be dividing by 0, that value, that input is restricted. So this particular function, right, its domain cannot include -3, right? So I'll just say this, -3 is not in the domain. So both of the things I'm talking about here are what are restrictions on the domain, and I'm not really talking about the range right here. But -3 can't be part of this function's domain, because if it was, it would cause division by 0, and at that point something's undefined. So you could say, if you were asked, hey, what's the domain of this function? You could say this, you could say all numbers, and you can even say real numbers, all reals except -3. Okay, so I would say the domain, right, what can go in this function is all of the real numbers except for -3. That's a lot. It's a lot of choices, but don't put -3 in there because it's not defined. The other thing that we've kind of stumbled on and we've talked about in class, or maybe you were remote learning that day, is the square root of a negative number causes problems. Now, that's a little problematic here, because it's like, geez, I don't know what exactly would make this become a negative number. Well, here's the idea. I know that 2x plus 1 cannot be negative. So say it another way, 2x plus 1 has to be more than 0 or it can equal 0. 2x minus 1 has to be greater than 0. And if I want to try and isolate and figure out what the domain of this is, I can just say this. Look, 2x minus 1 has to be greater than or equal to 0. And I could solve this pretty quickly by just go ahead and adding a 1 to both sides. So 2x has to be greater than or equal to 1. X has to be greater than or equal to 1/2. What that means, and I could verify this on a graph of this function, is this function is only going to give me values when x is larger or equal to 1/2. It can be 1/2. If I put 1/2 in there, that becomes 2 times 1/2 is 1. 1 minus 1 is 0. The square root of 0 is perfectly fine. Anything bigger is fine, right? If I put in x's, I'm trying to think of a nice number. If I put in x's 1, 2 times 1 is 1. 2 times 1 is 2. 2 minus 1 is 1. The square root of 1 is 1. So all those are fine. But if I put a negative, if I put something that is smaller than 1/2, if I, for example, put in 0, all of a sudden what I'm looking at here is this becomes, if this is 0, this becomes 2 times 0 is 0. 0 minus 1 is -1, and I've got the square root of -1, which is undefined. So those are two things to be aware of. Radicals have to be positive, and you can't divide by 0. And if I was going to say what the domain of this function is, I would say, let me grab a pen that is of a better color that you can see. on y. I could say for this function here, the domain of this function is just x. I'll just say like this: x is greater than or equal to 1/2. So that just says, hey, x's are all those things that are more than or equal to 1/2. That's the domain of that function. Okay, we are right at 20 minutes, so we're going to finish with this. This is question 55 in your ebook. It's not part of the review preview, it's part of the classwork. But what I want you to do with this is I want you to do these 6 and write down what the domain and the range are. And then, so you're going to pause the video, unpause it, and then just check your answers to calibrate and see how you're getting for defining or understanding range, domain, and range from a graph. Okay, so here are those answers. On the first one, this function is running from -3 to +3. So my domain are those x values, domain, 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 from -3 to +3. And the range from -3 to +3. This is clearly not a function because you can see many, if not all, except for probably the very ends right here at +3 and -3. All the rest of the values in the domain have 2 different outputs, right, above and below. The next one, there's arrows here that indicate it goes in both directions. So because I'm shooting down this way forever and I'm shooting up the other way, this one has a domain of all real numbers, and this range is all real numbers. This one has beginning and ending points, right? You can see there's a solid dot here, so it is including the -2, -1, -2. So the domain is from -2 to 4 and everything in between. So x's are those things that are greater than, the x's are larger than or equal to -2, and they're less than or equal to 4. And then my range is from -4, the smallest value, up to +2. So I can get everything from smallest to largest. And notice when I write these down, I always do put the smallest thing off to the left and the larger thing off to the right. For D, the domain is all reals. This curve goes down like this, and it's hard to imagine, but if you go this way in infinite direction, right, and there's no evidence that this is an asymptote, it's just going to continue forever going down and down like that. So the domain is all reals. However, the range is limited, right? I cannot get a value that's up here, right? I couldn't get 5 out of this function. The biggest value it looks like I can get is 4, and it looks like I get that when I put in x is -1. E is the other one that's not a function, right? A and E are not functions. For E, the domain is from 2 to 4, including those endpoints, and the range is from -3, that's the smallest, up to 2. That looks like the largest output value. And then finally, F, my domain, are all those things bigger than 0, right? As soon as X is over here, sadness, it's saying nothing. I put in -10, it's got nothing to say, right? As soon as I put in 0 or more, it starts talking to me. So my domain are all those values greater than 0, and the range are all those values greater than or equal to 3. You can see I'm not able to get 3 out of this, just those things bigger than 3. All right, we're going to have to call that time. This is Mr. Roberts. Thanks for watching, and I look forward to seeing you in class again.